Um, all right, guys. So we are at the last lesson in Unit 3, and it's the quadratic formula lesson. Okay? Quadratic formula. Um, so we've been building up to figuring out how to find, we've been trying to find solutions to quadratic equations. Not only does it help us kind of map out and manipulate these equations, it also allows us to find these critical points on these equations. Usually these are critical real life situations. Um, and so some of the things that we've done so far, you should now be able to recognize linear equations. They have at least one y term, one x term. They're both to the 1 power. You could add a number, you could subtract a number, do all kinds of things. You could put a number in front of each one of these, as long as the format looks like this: one y term, one x term, and possibly a constant term. So linear equations. Now the absolute value equations, that's when we have an x term inside of a absolute value bracket. You have a y term somewhere, and you could have a number inside. You could have a number on that's a coefficient of this bracket, or you could add or subtract a number. Regardless, that's what the absolute value equation, the characteristics of it, look like. Now, the quadratic itself, and it's important today that you understand, in general, looks like this. It has one y term, one x squared term at least. Okay? We could have a number in front of it, a coefficient. We could have an x term. We could have a number term. Regardless, this is what the quadratic looks like. And it's very important that you understand that as we move forward through this lesson. So we're going to get started. So this is the quadratic formula. And the reason I went through what the quadratic looks like is it's very important that you understand that these coefficients in front of this x squared term and the coefficient in front of the x term and the constant c, those are very important because they allow us to easily find solutions if we have the formula or if we can memorize the formula. So the quadratic formula is used to find the solutions, the roots, zeros, or x-intercepts of quadratic equations. The formula is especially useful when factoring is difficult or impossible. So the first thing we always need to do is to make sure that we have the equation in standard form. So it is, and you're going to next identify the a term. A is 2. It's in front of the x squared term. So I'm just going to write it above 2x squared. Put my x term next. There's a 1 in front when there's no number there. Minus 3 goes last. So b equals 1. It's the coefficient of the x term. And c is the constant, negative 3. So we're going to take the formula. I prefer if you write it out. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Okay? So part by part, this equals negative b is 1, negative 1, plus or minus the square root of 1 squared. And make sure you're using parentheses here. 4 times 2 times 3, and this is all under the radical, divided by 2 times 2. So this equals, we're going to simplify part by part. So I'm going to show you what we're going to simplify. We're going to simplify this. I'm going to put it right here. And then we're going to do something special and simplify what's inside of the radical and put that here. And then the last thing we're going to do is simplify the denominator. Okay? So going back to my pen here. And I'm going to put my divisor line here. put my plus or minus here, things I can figure out on my own. And what I have here is -1 plus or minus whatever's inside that radical. We're not going to touch it yet. And 4 on the bottom. 2 times 2 is 4 on the bottom. So I'm going to use my graphing calculator and put what's in the green into the calculator. Sorry. Okay, so I'm going to, not using the radical, just going to say 1 squared minus 4 parentheses 2 times 3. And it's very important that you do it this way. And I'll get to the reasoning for why in a second. So be careful that you include the negative in there, okay? So we get the square root of 25. And I want you to notice that this is positive, it's positive, and it's a perfect, write this down, perfect square, because we're going to be going somewhere with the type of root or the type of discriminant inside of here. What this simplifies to is equals -1 plus 5 divided by 4. I'm splitting off this part right here, and then -1 minus 5 divided by 4. So quadratics produce 2 different answers. Sometimes they're the same, but 2 answers at all times. The first one simplifies to -1 plus 4 over 4 is +1, comma, -6 over 4 is -3 over 2. So here's my answer. I'm going to put curly brackets around it. That means I have a root at +1, and I have a root at -1.5. So these are my x-intercepts. That's what the solutions are. This is where the curve crosses the x-axis. Next, I'm going to solve by factoring. So my original equation is 2x squared minus x minus 3. No, plus x minus 3. So remember, if you don't recall, when you're factoring with a coefficient in front of the x squared term, you take that first number and you multiply it by the last, and you end up with x squared plus x minus 6. And what we do with the slide and divide method is we divide it back out at the end. But first, let's factor. I'm looking for 2 numbers that multiply to -6, and they add up to +1. So the bigger number is going to be positive. So I have 6 and 1. Those don't work. I end up with 5, and up +5. And next we have 2 and 3. And if the bigger number is positive, then I do get +1. So my factors are x minus 2 and x plus 3. And remember, before we divided out we multiplied the 2, so we're going to divide it back out. We end up with this equals x minus 1 times the quantity of x plus 3 over 2. And remember, the solutions should be the opposites of those numbers that are included in the parts of the factor. So +1, curly bracket, comma, 3 over 2, and it's negative. And so my solutions are the same. Okay? Now, if I want to graph this equation, I just go to my graphing calculator, plug it in to y equals, and I have 2x squared plus x minus 3. Press trace. There's my graph. Look at the table to get some coordinates here and things I can use. 0, -3, 2, 7, -2, 3. Okay. 0, -3. And here's my curve, guys. All right. So we've used the quadratic formula for the first time. We got 2 roots with a perfect square. And this will make sense what I'm saying in a second. So because this number inside is positive and it's a perfect square, we produce two real roots. Okay? Moving on. Now, for the next problem, we have negative 5x squared plus 6x minus 1. Just going to write out my coefficients here. Everything is in standard form. So a equals negative 5, b equals 6, c equals negative 1. Write out my quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a equals negative plus or minus what's inside the radical, and then 2 times a number. So b is 6. I have 6 squared under here minus 4 times negative 5 times negative 1, and 2 times negative 5 on the bottom. This equals, I'm simplifying part by part, negative 6 plus or minus what's inside of that radical, I'm not ready for that yet, divided by negative 10. So I use my graphing calculator, put this information in here, go to second mode, and I have 6 squared minus 4 times minus 5 times negative 1. Let me go back and change that 5 to a negative. Okay, and I get 16. This is a positive number, so I'm going to produce two real roots. So 16 means I'm going to have two real roots. Okay, so simplifying, I get negative 6 plus 4 divided by negative 10. And over here, I have negative 6 minus 4 divided by negative 10. So simplifying, I get negative 2 over negative 10, or negative positive 1 over 5 for my first one. And over here, I get negative 10 divided by negative 10, or positive 1 for my second root. If I'm going to write this out in the correct way, you'll write x equals, curly bracket, 1/5, comma, positive 1. And here's my final answer. Next one, it's in standard form. I'm going to put a 1 in front so I don't forget. A equals 1, B equals negative 2, C equals 2. Writing this out, I get negative b plus or minus the square root of b squared minus 4ac divided by 2 times a equals negative whatever b is plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And what I just did was I just put parentheses first for the things that I'm inserting and plugging in. It's healthy practice, it's good practice. I get negative 2 here. Negative 2, 4 times a times c, and 2 times a on the bottom. So I'm simplifying. I get positive 2 plus or minus the square root of 2 times 1 is 2. So on the inside, I get, let's see, 2 squared minus 4 times 1 times 2. And I get negative 4. This is a complex number. Complex number. So we're going to produce two complex solutions. The first one, the way I'm going to break it down is I have 2 plus or minus. Now, going back to the last lesson, the square root of negative 4 would be like saying, let's find a clearer space here. Like saying the square root of 4 times the square root of -1, or this equals plus or minus 2i. And you can kind of see why we have plus or minus now in the formula, because you produce two solutions. So I have plus or minus 2i's divided by 2. Simplifying, you could go ahead and divide out these 2's first. So if you wrote it out, you have 2 over 2 plus or minus 2i's over 2. The 2's cancel in the first. You get 1 plus or minus 1i. And you could keep it in that form, but preferably you'll go ahead and write x equals curly bracket 1 plus 1i, and x equals 1 minus 1i. So for the last one, I do want you to do it on your own, but first you have to make sure it's in standard form. All terms are on one side and they're in order, and they are not. So we're going to add 4 to both sides, and I come up with x squared plus 4x plus 4. Okay? Now we have a being 1. There's a 1 in front of the x squared. B equals 4. C equals 4. Actually, I'll do this with you. So we have our formula, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a, which equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4 divided by 2 times 1. We get negative 4 plus or minus the square root of 16 minus 16 divided by 2, or equals negative 4 plus or minus the square root of 0. This is going to produce the same number. One number, okay? When you get 0 inside, you're going to produce one real root, or one solution. This is a one solution type of quadratic. This equals just negative 4 divided by 2. So x equals curly bracket 2, or to make more sense for you, it would be curly bracket 2, comma 2. Either one works. Now, the last thing we want to go over is the properties of a discriminant. So, the discriminant is the portion, it will tell you how many solutions and what type of solutions, whether they're real or imaginary. So I told you earlier that if you produce a perfect square, you're producing two real solutions. So if everything inside of here is a perfect square, I'm producing two real solutions. So the first thing we need to do, the discriminant is the part of the quadratic equation that I've been going over with you. I want you to be mindful of what I'm talking about. Negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. So the discriminant is the portion inside of the radical. I've been telling you over and over to look at the type of number that's produced. So if we're producing a perfect square, we can automatically answer questions about whether we're getting real and rational solutions, or one real solution, two real and irrational solutions, or two imaginary or complex solutions. Okay? So first, a equals 1. That number in front is 1. B equals negative 7. And C equals 6. So plugging these inside, I get the square root of 1 squared minus 4 times, negative 7 squared. 4 times A is 1, and C is 6. This equals the square root of 49 minus 24, or the square root of 25. So if it's positive, if the number inside is positive, and a perfect square, you will produce two real and rational solutions. If you graph the equation in your calculator, you'll find that you have a solution at this one and x minus 6. Your graph looks something like this. You have two solutions. One's at 1 and the other is at 6. Equals 1 equals 6. Okay? Now, the next one, we're going to produce one real solution. This is where you get 0 inside of the discriminant. So here, a equals 1, b equals 6, c equals 9. I get the square root of b squared minus 4ac, or the square root of 6 squared minus 4 times 1 times 9. And I get the square root of 36 minus 36, or the square root of 0. So producing 0 produces one solution, one real solution, and this solution just happens to be at -3. And that means the curve hits the x-axis at one point only. For x squared plus 1, you're going to produce two imaginary solutions. Okay? So this is what it's going to look like. You're going to produce a complex number. Oh, actually, take that back, but not before then. You're going to produce a negative perfect square, a negative number under the radical. Okay? So a, let's rewrite this, x squared plus 0 times x, there's no x term, so we say 0 times that number, minus 1. A equals 1, b equals 0, c equals -1. Putting it inside of my radical, I have the square root of 0 squared minus 4 times 1 times -1, and this equals the square root of 0 minus 4. Sorry, this is a positive 1. This is a positive 1. So 0 minus 4, this equals the square root of -4, and inside I produced a negative number, so I'm going to produce two imaginary solutions. So I'm going to graph my curve. It falls above the x-axis. In the last one, we're going to produce two real and irrational solutions. So they're real, but they're also irrational. So a equals 1/2, b equals 3, c equals -2. Putting it inside the radical, I get 3 squared minus 4 times 1/2 times -2. Simplifying, I produce 9 minus 4. This equals the square root of 5. And what I produce is a number, a positive number that is not a perfect square. Okay? When I produce a number that is not a perfect square but is positive, I'm producing two real and irrational solutions. And my graph, it's a little bit harder to graph, so we're going to go look at it. Clear. Have alpha y equals, enter, 1/2 times x squared plus 3x's minus 2, and press trace so I can look at my graph here and look at it over there in the second, third quadrants, second, third, and fourth quadrants of this graph. I'm going to go ahead and graph that. 2, here's my curve. All right. And that's all she wrote for this lesson. So I hope that that works for you. Go back and look at the video, but you should try the next ones on your own. Use the quadratic formula to solve the following. Show all steps, leave radical answers in radical form. For the homework number 5, you're going to be using the quadratic formula. They want you to give the discriminant of each equation and determine the nature of the roots, as well as, I think, not much beyond that, as well as the back where you're using the quadratic formula as well. So touch back with the video if you still need help. Also use Khan Academy. You will have an assignment when you come back to class for the review during class. So you'll have to do the review. That's the paper document on your own. Have a good day, guys.